Hello, today we're going to be talking about exponents and division. So we're going to be going over two new properties. So we're just going to dive right into the examples. So the first thing we have here is dividing powers with the same base. And what I'm going to do is, what they're showing you here is that when you have a base of 7 and another base of 7 here, and it's 7 to the 8th divided by 7 to the 3rd, if we thought that this was multiplication between those, you added the exponents. When you do the inverse operation of dividing, you're actually going to subtract the exponents. So again, just to show you though, if you have 7 to the 8th, that's equivalent to 7 times 7 times 7 times 7 times 7 times 7 times 7. 1, 2, 3, 4, 5, 6, 7, 8. All divided by 7 to the 3rd. So that's going to be 7 times 7 times 7. And if you think about being able to cross these out, if you have a 7 divided by a 7, they cancel out. And a 7 divided by a 7 also cancels out. Another 7 divided by 7 cancels out. So you're left with just 7 times 7 times 7 times 7 times 7, which is equivalent to 7 to the 5th. So in algebra, again, that if you have an a to the m divided by an a to the n, both of those have a base of a, all you need to do is subtract the m and the n. They are also telling you that a cannot be 0 because you cannot have a 0 in the denominator. You can't divide a number by 0. So again, these examples are pretty straightforward for you. They're reminding you what it is that you need to do. So I'm just going to have you guys go ahead and practice those three. So again, I think these are pretty self-explanatory because they're guiding you through the examples. So check over your answers. And then I'd like to also practice this one right here, 4x to the 5th divided by 2x to the 2nd. And I tried to mention this in class again, that the base is technically only the x. The base is not 4x. The base is the x, and then the 4 is the coefficient. The base is the x, and now the 2 is the coefficient. So you can only apply the laws of exponents to the base and the exponent. So the 4 divided by 2, you do just go ahead and divide them out. So 4 divided by 2 will be 2. And then x to the 5th divided by x to the 2nd, you end up subtracting those exponents to get x to the 3rd. So for example number 2, we've got g to the 35th and g to the 23rd. Again, the direction says to simplify, so all we're doing is applying the laws of exponents. So this is g to the 35th minus 23, which will equal g to the 12th. Sorry, speak over the microphone. For question number 3, they're asking, does a to the 12th and a to the 8th have the same value as a to the 6th and a to the 2nd? So for this one, I would do a to the 12th minus 8, which would be equivalent to a to the 4th. Over here, I would do a to the 6th minus 2, which would be equivalent again to a to the 4th. So yes, they have the same value, and my work is my justification. Now moving on to our next law that says power of a quotient. It says to find the power of a quotient, raise the numerator and the denominator to the power, and then simplify. So in this scenario, this is really saying what is 3 to the 4th, the numerator, and what's 5 to the 4th. They're breaking it down for you, so I'm not going to break this down any further. And then since their base is actually a number, they went through and simplified that 3 to the 4th equals 81, and 5 to the 4th is 625. So again, in algebra, they are showing you that a and b cannot be 0, otherwise you won't be able to use the rules. So as you can see, these examples, they don't break it down for you as much as they did on the ones in the front. So be careful here, because not only in this numerator is it just a base, it's a base and an exponent. So this is really equivalent to a to the 7th, and then you have to stop and think about this. Are you going to add these exponents, or should you be multiplying these exponents? Well, this is going back to our previous law of a power to a power, which meant that we now have to multiply. So this is 7 times 3. And then down in the denominator, this is 5 being raised to the 3rd power. So then to simplify this, I would have a to the 21st, all divided by 5 to the 3rd, which is 125. And you just leave your answer like that. Now practicing B, this one in the numerator has a coefficient and a variable and an exponent. And again, the denominator has a coefficient and a variable. So be careful here how we work this. Remember that only the base and exponent is being, you use the laws of exponents. So technically, that 2 is separate from the x to the third, so you are raising that 2 to the second power. And then x to the third, and again you have to think about how do you combine your 3 and the 2 here. You would be multiplying them by powers of exponents. All divided by the 3 to the second times the y to the second. So when we simplify this, it will become 4 times x to the 6, all divided by 9 times y to the second. And if you could have reduced these, you would go ahead and reduce the 4 and the 9. In addition, if you could simplify, because this was an x and this was also an x, you could now apply your laws of exponents that we learned from the front. I'm going to have you guys go on and try number 5, and then when we get to 6, I'm just having you guys rewrite the questions nice and large, so I'm just going to leave that there so that you can give yourself a little bit more room. You might even want to get a separate sheet of paper out for the second one. Okay, so be careful here. That says 256b to the 12th. My 6 and my b look very similar. So again, you have to take the a is separate from, or excuse me, the a to the second is the base, so then you would be multiplying the 2 and the 4, the exponents. On the denominator, the 4 is separate from that b to the third, so I'm applying 4 to the fourth times b to the third times 4, and simplifying that out. So now for number 6, I'm going to do these next two with you. You need to make sure you're very careful here. We are applying the third power to the 2. So this is going to be 2 to the third times r to the 9 times 3. Because you have the r to the 9th being raised to a power. That's a power raised to another power. Then in the denominator, that 3 is also being raised to the third power, that coefficient. So that's going to become 3 to the third times m, and then that will just be to the third power. So to simplify this, this will become 8, and then r to the 27th divided by 27 m to the third. And since I can't simplify 8/27ths and I can't subtract the r and the m because they're not like bases, that is my final answer. So the next one, there is multiple ways that you can do this question, but I'm just going to break it down here for you because there's a lot happening. So we have 2, which is a coefficient, and then we have 2 different bases here, the d and the g. We have the 4 that is the coefficient, and then 2 bases, which is the s and the w. And everything that is inside those parentheses is being raised to the 5th power. So it's not even just separate terms, because terms are technically separated by addition and subtraction signs. It's the coefficient and the bases separately are being raised to the exponent. So this is going to become 2 to the 5th times d to the third times 5 times g to the 12th times 5. All over 4 to the 5th times s to the 12th times 5 times w to the 6th times 5. And then we simplify. So 2 to the 5th is going to give us 32, d to the 15th, g to the 60th, all over 1024, s to the 60th, w to the 30th. And at first you might think that that is our final answer, but if you look at 32 and if you look at 1024, both of those numbers can be divided by a specific number, and that number happens to be 2 to the 5th power. No, so 32. 32 for both of these. If you go and do 1024 divided by 32, it gives you 32. So technically your final answer is going to be just d to the 15th, g to the 60th, all over s to the 60th, and w to the 30th. That technically is your final answer. Okay? So if you have any questions, I'm sure we'll go over them tomorrow when you're doing your homework. Thank you, and have a great night, guys and gals.